Problem 26. A college student on a 7-day meal plan reports that the amount of money he spends daily on food varies with a mean of $13.50 and a standard deviation of $7. Okay, so what are the mean and standard deviations of the amount he might spend in 2 consecutive days? Okay, so what here, this is a continuous random variable that we've been given, and so all they're asking us to do there is just find, let's just call it the amount that he spends. We're just going to call that x, okay, to keep things simple. And so what's the expected value of 2 days? So that variable is going to occur twice. So all that is the expected value of x plus the expected value of x. So that's just 1350 plus 1350. So that should be $27, right? $27. Okay, now the variance, so to find a standard deviation, we have to start with the variance. So the variance of a random variable plus a random variable, we just add the variances. So that's just going to be the variance of x plus the variance of x, or if you want, 2 times the variance of x. So the variance, remember, you have to remember that the variance is always the standard deviation squared. So the variance of x is $7 squared. Okay, so this is going to be 2 times 49, right? So that must be, that's going to be 98. So the standard deviation of x1 plus x2 is going to be the square root of 98. Okay, and that should be 9.9. Don't really want to do that on my calculator, but I think that's it. Okay, so that gets us through problem A. What assumptions did you make in order to combine the standard deviations? Well, they have to be independent. Okay, so that's the main thing. When we combine these variables like this, they have to calculate the variances, they have to be independent. Which I think they are. Although I guess you could say that if they spent too much money on one day, then you might cut back the next day. But at least we're going to make an assumption that what you spend from day to day is independent. So we're going to state it as an assumption. Okay. So estimate the average weekly food cost and the standard deviations. So that's what we did. With C, oh, weekly. Okay, so what we did was A. This was A and B. So weekly, that is 7 days. So that's going to be the expected value of x1 plus the expected value of x2 plus ... because I'm lazy, 7 days. Okay, so that's just going to be 7 times 1350. So what's that come to? About 94.50. Okay, so then the variance of x1 plus x2 ... x7, well, we just add the variances. So instead of writing it out, I'm just going to be lazy and write it like this. So it's 7 times 7 squared. So the standard deviation is going to be the square root of 7 times 7 squared. So that's 7 times the square root of 7. And so I think that's going to be 18.52. That's what I got when I did it on the side. Okay, so that's all we're doing with this problem, is taking the information that they give us for a continuous random variable, and then we looked at the expected value and the standard deviation for one day and then for an entire week. So you had to kind of figure that out, and as you can see, it took me a second to realize that they were actually asking for a second problem, but a week would imply 7. Okay, do you think it likely he might spend less than $50 in a week? Explain. Well, let's see. Assuming once again that spending on different days is independent, it is unlikely that the student will spend less than 50. This level of spending is about 2 standard deviations away. Okay, so yeah, if we look at what he's expected, 94.50 minus 50 is 44. So that's about 2 standard deviations away. So they didn't say it followed the normal model, but if it did, that would be 2 standard deviations away. Okay, so the probability of that would be pretty small. So probably not likely. Alright, so that's how you do this one. Good luck with that.